welcome to this webinar brought to you by MRS Houston Gulf Coast branch. Before we go into the webinar, I want to invite the MRS Chief Executive, Gwen Lewis, who took over the helms of affairs as CEO of the MRS at the end of June, to say a few brief introduction to the branch and the wider MRS community. So, Chris.
Thank you very much, Nimi, and good morning, good afternoon, and good evening to everybody joining the webinar. Firstly, just to say that it's a huge privilege and honour for me to have been appointed as the Chief Exec of IMarEST and to have succeeded David some 3 months ago. I'm still very much a new boy and learning the ropes, but the branches and the activities of members through the branches and the SIGs is absolutely paramount to our future. So I'm really joining the webinar to enjoy Pete's presentation and to learn a little bit more about the branches, how they work, and the interactions that you have. But I think we've got a few moments, perhaps, if anyone has any immediate questions, I'd be pleased to answer them, or alternatively, contact me via email at the Institute's offices. Thanks, Nimi.
Yeah, thanks, Gwen Lois. So, our speaker for today is Peter Noble. Peter Noble is a naval architect, marine and ocean engineer with a wide range of experience in the maritime and offshore sectors. His career began as an apprentice draughtsman at Denny Bros shipyard in parallel with attending University of Glasgow. His career has included positions with shipyards, with ships and offshore design consultants, with offshore and marine research and development companies, with major classification societies, and a chief naval architect with the International Oil Company. For our global viewers, please note that this webinar is a listen-only mode. So kindly use the Q&A chat box in Slido to send your questions, which will be addressed by the speaker at the end of this presentation. With that, I hand over to Mr. Peter Noble. You have our full attention.
Thank you for that introduction, and I'll just say a Texas howdy to everybody listening, whatever time zone you're in. One of the things I've learned in my at this stage of my career that a good way to actually communicate knowledge is through storytelling. So I'm going to tell you a story today. In order to make it a little more sophisticated or maybe academic, I actually have coined the term narrative knowledge transfer, but it's basically telling stories about our industry. The other thing to remember is one of my favorite quotes from Mark Twain is, "History doesn't repeat itself, but it often rhymes." And so today I'm going to talk about a bit of history, but I think you'll be able to see some rhymes that might be useful today and tomorrow. Just some background before we start is the reason that I put this presentation together was a few years ago, I think maybe in 16 or 17, I was working with some students at Texas A&M Galveston campus, and they're on a little island. And as I drove across this narrow bridge, as I'm wont to do and scare my wife, I was looking to the side to look at the ships in the channel, and I saw this odd-looking ship berthed opposite where the campus was. I pulled into the parking lot and took a closer look and realized it was a ship called the Sturgis that I knew a little bit about. And so that was fine. And she was there for decommissioning. We'll talk about that later. But the other event was more recently when I saw lots of excitement in the maritime press that the Russians had built the world's first floating nuclear plant. And I thought, no, that's not quite right. So those are the things that really set me off to put this together. So I hope you'll enjoy this presentation. A couple of antecedents to this activity, this specific activity, were during the Second World War. The Liberty Ship Program, which was the construction of close to 3,000 merchant ships over a 3 to 4 year period, and we'll talk a little more detail about that, but you can see in the left-hand slide some of those ships, and they were amazing production lines in a number of shipyards. And the other was the Project Manhattan, which was the development of the atomic bomb. Just a quick word on the name Manhattan. I had never realized where the name came from until I was doing some research on this. But Project Manhattan was under the Corps of Engineers, the Army Corps of Engineers, and I'll talk a little more about them later. And they are organized and still are under districts. So we have the Galveston district, we have the Louisiana district, various districts. But in order to control the development of the atomic bomb, they created a new district because they had their offices in New York, and they called it the Manhattan District, and that translated into the name of the whole project to develop the atomic bomb.
Yeah, Peter, can you put on your screen?
I'm sorry?
You can see your slide.
Oh, I'm sorry. I have it up on share screen. Are you able to see that now?
Yes, and you can actually put it on.
Yeah.
Good.
Okay, I'm so sorry.
Yeah.
I practiced, but obviously not practiced enough. Okay, well, these are the first two slides we went through, or these two. Now we'll go into the real background. So the Liberty ships were an amazing program. 2,710 Liberty ships were built over a 4 or 5 year period. That's an average of 3 ships every 2 days. That's a little faster than we build ships today. They were sizable ships, 440 feet cargo ships, really built to do North Atlantic supply between the US and Europe. And triple expansion engines, OFR at about 11.5 knots, dead weight of a little over 10,000 tons. The Sturgis, which is the ship that we'll talk about that eventually became the floating support for the nuclear plant, was built as a Charles H. Kugel. And she was built right at the end of the war, which was one of the reasons she became acceptable for their conversion, built in just about 50 or 60 days. But she was built as a special design. The Liberty ships were standard ships, but as things progressed, they actually made some of them specialized. So what we see here was as a boxed aircraft transport, which changed the hatch configurations and the loading gear. But she didn't see much service, and after the war, she was laid up for several years in the US Reserve Fleet. But in 1964, she was identified as a candidate for conversion into the world's first floating nuclear power plant, and was transferred from the Maritime Administration to the US Army. On the nuclear power plant side, the Manhattan Project, run by the Corps of Engineers, as I mentioned, looked at producing a weapon. But at the same time, there were parallel interests in looking at nuclear power for land-based military needs. And in '54, the Secretary of the Defense assigned the Army the responsibility for nuclear power plants to supply heat, electricity at remote and relatively inaccessible military installations. And they built a number of these, and we'll run through the list, but these were places like remote nuclear missile sites. They were looking at sites in Antarctica, in Greenland, and other places for relatively low power. And so at the same time, the Chief of Engineers for the Army set up a nuclear group to conduct R&D with the Atomic Energy Commission on nuclear power plant development, to operate Corps of Engineers nuclear power plant, to carry out training and provide technical support to other agencies. And in fact, they provided support from the Army to the Navy as the Navy nuclear program started. The Army set up a center at Fort Belvoir, which is just down the Potomac River a little bit from Washington, DC. Maybe not the smartest place to develop a whole nuclear research facility, but in those days, that's what happened. And they produced a number of different sizes of units, from 200 watts to 2 megawatts. And but the largest was the 10 megawatt plant that we're going to talk about today. And that was built as an idea of having a decent amount of power that could be transported in theater to different operations. It was not developed for a specific activity, rather it was still an experimental facility. So the MH-1A, which stood for Mobile High Powered, was a single loop pressurized water reactor. It's a fairly simple system, and it was fitted inside a 350-ton containment vessel. And so the need to have something to actually transport that, obviously, we all know as marine people that the way to move heavy loads about is to put them in something that floats. So we look at what happened to how these two elements, the well-used Liberty ship and the nuclear power plant, were put together. And this is a cross section. basically there was an additional midship section built. And the midship section in this that was installed is from the house aft. And that was built to contain the nuclear components. And a little bit forward of that was actually the steam generation. And then in the bow, you'll see some pylons where the electricity was actually transmitted to shore. And so the Kugel was brought to Mobile, Alabama, and put in the dry dock and cut in two. And a new mid-body was erected. We're looking from the stern forward to where the house is now, but this immediate section closest to us, closest to the photograph, was where the nuclear plant was installed. And when this was completed, the modified ship was brought back to Fort Belvoir on the Potomac and moored there for the installation of the reactor systems. And the testing was taken, it took 5 months, and basically everything was commissioned as thought. An interesting little side note, those of you that remember back to those days, this was at the time of the Vietnam War. And it was briefly thought that the Army might take that to Vietnam, but the State Department quickly decided having nuclear things in Vietnam was not a good idea. So the vessel, as I said, the vessel was not designed for a specific location or theater. It was designed as an experimental facility that could be mobile to provide 10 megawatts of power where it might be needed. Very shortly thereafter, however, it became clear that the US Army had a responsibility where they could actually use this. The US Army Corps of Engineers although it's a military organization, has a large civilian component in the US. The Corps of Engineers is responsible for things like shoreline maintenance, dredging, dam safety, locks, and other systems. And as such, they had responsibility for operating the Panama Canal while the US controlled the Panama Canal Zone. Now, as most of you realize, the Panama Canal and other canals are actually driven by rainfall. You need to have a head of water in order to pass through the locks. And as each lock is used, that water generally runs downhill and goes away. Panama even now has an issue with, from time to time, with droughts. But back in the middle 60s, there was a big problem occurring where there wasn't enough water to run the lock system and concurrently run a hydroelectric power station from the Gatun Lakes, which was supplying power for the system. And so the Army Corps of Engineers came up with the idea that if they moved the floating nuclear plant to Panama, they could use that to produce the power and substitute the water that would be consumed by the hydroelectric system and use that for actually running the canal itself. So in October 1968, the 10 megawatt power was produced by that was allowed to replace the power from the lake. And this freed up water. And I've seen estimates that say the water that was saved allowed 15 additional ships to pass through the canal every day. So it was significant improvement in efficiency by having this separate power source. And you can see the vessel there tied up alongside. You can see the power cables at the bow coming to the shore from the system. But the vessel basically was moored alongside and did that successfully for quite a few years. One of the interesting things when we think about nuclear safety today is, nuclear ships are not refueled very often today, naval vessels. In fact, some of them are almost lifetime things. But in those days, the plant needed refueled. And in fact, this plant was refueled almost once a year. Refueling took place in situ in the canal and took about 1 week to complete. I'm going to do some more digging into that because that seems like an interesting feat, and I don't know who was involved and how it was done, but that's what actually happened. So the vessel was refueled, I think, 5 or 6 times between 1968 and 1975. By 1976, the water levels in the Gatun Lake had returned, and the Army decided that it was time to decommission that plant and move it back to the States. And so it was brought back. It was basically decontaminated, and physical barriers to prevent the release of radioactivity were installed. It was defueled and put in safe storage in the Savannah River site. and moored up, and finally moored up in the James River site off Chesapeake Bay, where a lot of the other reserve fleet are stacked. By 2014, the Army realized that they had to do something about this. They couldn't just sit there. They weren't going to use it again. And so they awarded a contract for decommissioning, dismantling, and disposal of the nuclear reactor. The nuclear reactor had been defueled and decontaminated earlier before it was put in the James River fleet. But following the decommissioning, the Sturgis was relocated to Galveston, Texas, just down the road from where I am right now, with the idea of removing the residual radioactive material. The containment vessels and some of the other components surrounding the reactor still represented a nuclear radioactive hazard. So the ship was towed into the port, and decommissioning started in 2015, 2016. Just a little side note, the US was also in about the same time frame playing with nuclear cargo ships, and this is the most famous vessel, nuclear ship. There are other nations were doing that too. The Japanese had the Mutsu and the Germans the Otto Hahn, but they faced not so much technical difficulties, but public acceptance. It was hard to come into a port with a nuclear ship, and probably still today true. However, the Savannah, when she was going to be defueled before layup, was brought to Galveston also to have its nuclear material moved in 72. Ship's now in Baltimore, and she's in my eyes, a fine-looking ship. But it's the days are gone when we'll see that. Although I believe there may be a future for nuclear power in the marine world, but it's going to be some time off. The reactor containment vessel, which is the outer vessel, the reactor is gone at this stage, but the reactor containment vessel, which held the nuclear fuel within the power plant, was lifted out. Total of about 1.5 million pounds of radioactive waste was safely removed, and about 600,000 pounds of lead sheathing. And you can see in the photographs the disassembly taking place on board the ship. That nuclear waste was placed inside special containment systems for shipping and delivered to a nuclear waste control site in Andrews County, Texas. And for those of you that know Texas, you'll know it's in the sort of northwestern part of the state, north of Midland, Texas, and it's a pretty empty part of the state. For those that don't know it, take a look at the map of Texas, because it's you can tell from my accent I'm not an original Texan, but I do understand the size of the country. You can drive 10 or 12 hours and you're still in Texas, so it's a big state. And so this is safely put in a waste control site in Andrews County. There were other pieces of kit. I mentioned that the nuclear fuel was refueled on a regular basis, and they were actually on board containment vessels for spent fuel rods and spent control rod systems that also had to be removed. And we see that being lifted out the ship's hatch. So now we come to the final chapter. The ship the nuclear material, any contaminated material, had been removed, but there was still the disposal of the ship itself. And that was rigged for tow and taken from Galveston, which is in the upper Texas coast at the mouth of Galveston Bay, for those of you looking at any maps. And it was taken to Brownsville, which is the most southern coastal community in Texas, right on the mouth of the Rio Grande, and basically as far as you can go in Texas before you hit the Mexican border. And there's a number of shipyards and ship repair and ship breaking facilities. So the vessel was taken there in 2019, and by the end of 2019, all of the steel had been recycled, about 5,800 tons of steel from World War II, and gone into recycling the vessel from Port of Brownsville. I'd just like to acknowledge a few people. I used to be with ABS, and I had help of a few of my ex-colleagues there to dig into some of the history of Liberty ships and also Tom Johnson from the Houston Maritime Museum and Education System helped a little. He was familiar with Savannah's visit to Galveston. Also, as I finished up working on this presentation, I actually found an excellent document which had been sponsored by the Corps of Engineers, which goes into a lot more technical detail on the deactivation of the nuclear power reactor barge Sturgis. So if you want to get more details, that's a great place to go. And that's it. I'm open for questions now. Thank you.
Thank you. Thank you, Peter Noble, for the well-delivered presentations. So we have some few questions here.
The vessel was removed because the water supply was improved and the power was no longer required. I'm looking at more details as the exact timing, but of course now the Panama Canal has additional locks, and one of the things with the new lock system is it has a better utilization of water. So it's still a challenge to have enough water to move ships through the canal, but it's less so now. It was recognized when they built the widened canal locks that they should have a water conservation system associated with those. So I think it's unlikely we'll return to that. There is, however, I think, renewed interest in floating nuclear plants, as we saw in Russia. The idea we see on land-based plants, a lot of nuclear plants are what I'd call stick-built. They're built in situ, which is quite expensive and also leads to quality control because typically you build them in remote areas. And the concept of building a nuclear plant in a facility which specializes in that and putting it on a barge and moving it to where it's going to be used seems to be a sensible approach, provided that you're happy with the safety that comes from that. And I think we'll see that, not quickly, it's going to be a long haul, but I believe that nuclear power will be a component of our future energy transition alongside renewables and other efficiencies in today's energy market.
Good. So our next question here is that did the reactor lead to any further developments on portable land-based systems?
The Army and actually other installations go ahead in small scale. The Army does have small scale units they deploy, but they keep it quite secret these days. They're not civilian activities. Nuclear power is used in some satellite systems. So the small scale nuclear plants do exist and are in use today, I think almost exclusively, for military purposes. But there's a lot of new technology in molten salt reactors and other things that are coming to the fore, which look like they're safer and more cost effective than the older style nuclear. But I honestly believe that these things are generational in application. I mean, I'm getting old these days, and I think it'll be at least 25 years before land-based new reactors are accepted, and they'll have to be accepted before marine components of those are. So it's a long horizon, I think, but it's one that takes time to develop. So it's important that people are actually starting to look at that now. And from that point of view, I go back to my comment about Mark Twain is about history not repeating itself, but looking at the rhyming, because there are lessons we can learn probably from the Sturgis as we look at future plants. What were the good things? What were the bad things? What lessons did we learn?
Good. So what would you think about the use of MSRO in shipping?
I'm a fan of that, but it's a long way off, as I just said. I think, although I don't know, I have a kind of niggling thing in the back of my head that the Chinese might do something and surprise us all. The big problem with the shipping component is not the technical issues. I think these can be solved relatively quickly. The big problem is the public acceptance, what I'd call the societal license to operate. And that's what killed the Savannah and the other ships. Basically, people built a ship and they had a Home Depot, but any place the ship tried to sail, people said, no, we don't want a nuclear ship here. And the fishing boats would blockade the port and all kinds of things. You know, I could see the Chinese, though, doing something. They're very progressive in their shipbuilding activities. And maybe they get round the deal by saying, well, we want a big container ship between two ports, but maybe one port isn't in the US, maybe it's in Mexico, maybe it's in Central America, that they might be able to get a specialized port that would receive nuclear power and then transship into the US. So there are there are potential activities there, and I think it makes a lot of sense in terms of being green energy. You know, if you do it right, nuclear should fit that that advances. I mean, we have a long history of nuclear vessels. They just happen to be mostly in submarines. Although, you know, part of my experience has been in icebreakers, and the Russians have done very well with nuclear icebreakers in places where you want a sister power system that's not emitting black smoke from burning heavy fuel all the time in the Arctic. So,
Yeah, well said. So, do you see floating power plants as any future in the energy mix?
yeah, I think we've seen over the last couple of decades floating, or maybe a little longer, floating power plants in general. Today, what we're seeing a lot of is LNG powered floating power plants, where you can have a clean power system run on natural gas, liquefied natural gas, delivered to places in islands in the Caribbean or other remote facilities where it may be hard to build an onshore plant, or it may simply be one of the things I've noted in work I've done there is the financial people and the banks quite like a floating plant, because if people stop paying for it, you can take it away. Whereas if you build a power plant on the shore, bolted down to a concrete base, that's a little harder to repossess. So there are some issues, but I think power plants in general, floating power plants do have a place, and it's a growing activity. Nuclear ones, I think, are still some way away. I think gas-fired floating plants are probably going to keep a steady increase in activity.
Good. The moving of the reactor to the Panama Canal site pose any serious regulatory issues in the States, or would it actually have any issues if this is actually relocated?
Well, the Sturgis was, of course, under US military control. And at the time, the Panama Canal Zone was actually under US military control. So there were no issues about that. Although I'm not sure anyone asked, you know, we had to tow it across the Caribbean, and I'm not sure anybody said anything to anybody. The ship was just taken to the Panama Canal. It was at the Caribbean end of the canal that the power station was. In future, yes. I mean, regulatory issues will be a problem. Although I think more than regulatory is what I said, it's a societal license to operate. So it's not, you know, you may get a permit from the government to operate things, but you still have to convince society it's a good idea, and you probably have to face protests. Just a little side story there. I remember being in Seattle at one stage when Shell wanted to take a rig up to the Arctic, and they had all the permissions and all the licensing to do that, but they had 400 people in kayaks surrounding the rig protesting that. Now, the irony is the protesters were all in kayaks that were made from hydrocarbon products. They weren't from sealskin, but that's kind of an aside. But you have to have not just the regulator, but for something like this, you've got to have societies buy into that, and that takes time. So I think that's why I'm not thinking there'll be a rush to do this. It'll be a steady progress. People have to gain experience and gain confidence in the technology.
That was the last question so far we got from our viewers. We want to say a big thanks to Peter Noble for the way he has actually delivered this webinar. And of course, much thanks goes to our viewers and those who are able to ask questions on this webinar. Thank everyone who are able to join this webinar. Well, thank you, everyone. Do have a great day.
Thank you all.